Okay, so we have a function here. F of x is equal to x squared e to the x. Okay, and what we're going to use is the product rule. Now they also have a quotient rule, which we're going to talk about next, but right now we're going to use the product rule. However, if you can, I would use the product rule all the time, if it's possible. Most of the time you can use the product rule even though it's in a quotient. You just turn the quotient into a product. Okay? Because remember, all the quotient is a negative product, or an exponent. A negative exponential product. Okay? So, let's just do this. Right here, first thing we're going to do is find the derivative of the first function. Remember, there's this one, and then there's this one, right? There's an x here. So wherever you see an x, is where another function is. Whether it's that this is an exponential function, so you have to use your exponential rules. Okay? And we'll talk about those in a minute. But now with this one, it's really simple. You just, with the product rule, we take the derivative of the first one. So first derivative, just like the power rule, 2 times the coefficient, so 2x minus 1 from 2, and you get 2. Or you get 1, right? And then you just bring this down, times what's ever here. So e to the x. Okay? So it's just the derivative of the first one times the second function. So it's actually the first derivative times the first function, or the second, so function 1, function 2, all right? And because we're doing product rule, what do you do when you add x, when you multiply powers? When you multiply when you multiply two powers, you add the exponents, right? 2 powers with the same base. You add the exponents. Same thing's going on here. When we're doing a derivative of a product of 2 functions, we're going to do the derivative of the first function times the second function plus, right, the derivative, or the function of the first function times the derivative of the second function. Okay? So, I just have to take the first function, which is x squared, and times it by the derivative of the second function. Now, here's the thing. When you're finding the derivative of a exponential function, such as 3 to the x or e to the x, when you take the derivative of this, you find the ln, right, of 3 times 3 to the x. Okay? Same thing here. When I'm finding this derivative, say this is f of x, and this is g of x, then f prime of x is equal to ln 3 times 3 to the x. G prime of x is equal to ln e, because that's the base, times e to the x. One cool thing, if you remember, back in pre-calc 2, pre-calc 1, we learned, and did we do logs in the very beginning of the class? I think we touched on them, huh? Yeah, we went over some logarithms because we wanted to revert back to way back to 103 and bring up your logs. So if you remember, we talked about these logs, and remember the ln with the base of what you're taking, remember ln has a base e, right? So ln is the natural logarithm base e of e. Well, that just is 1. So what's 1 times e to the x? Well, that's just e to the x. So the first derivative of this is really simple. It's just the same thing, right? So now the first derivative of this is a little different, right? ln, so the natural logarithm base e of 3 is not just 1. And that's where it's a little different. So when you have 3 to the x, it's different than e to the x. Okay? Alright, so we come back to this problem, and we are actually taking the derivative of e to the x, which is actually equal to ln, so times the ln of e times e to the x. But remember, that's just 1. So we rewrite this as 2x e to the x plus x squared e to the x. And what's nice here is, okay, you see anything in common? The e to the x's? So we pull those out, and we got e to the x times what's left inside, 2x plus x squared. Now this is the way they like to leave it. Actually, they like to leave it e to the x on the outside. I would prefer writing it like this, x squared plus 2x, and I would put the e up front. But I don't care which way you do it. Doesn't matter. They're all the same. Okay? There you go. Fun, huh?